Alright, let's start.
Good morning, my name is Anika. I'll make the first part of our presentation. The topic for our group was can thinking happen without feeling. So the first day we sat down and tried to define thinking and feeling, and we had problems. We had big problems. Because each of us had different definitions and understandings of each of the words. Some of the terms which came up as possible meanings of thinking means logic, reason, problem solving, and intelligence. And some of the possible meanings of feeling was sensing, perceiving, emotion, qualia, and intelligence as well. And it came up on this side. So we were all very confused. And so we decided to take a step back and just think of thinking and feeling as modes of responding to the environment. So we developed a model of our own, which like Group4 did. And we called the model the FT model. I'll come what FNTR, even though it's quite obvious that FNTR based on our topic. And so we began with this basic understanding of thinking and feeling as modes of responding to the world. So to develop our model, we go back to evolutionary time and we begin with it's messed up. The models are one slide was deleted. I'm really sorry about this. Okay. One slide was deleted from our presentation, so I'll just use the backup. Okay. So, thinking and feeling is modes of responding to the world. So, if we begin with the evolution, we have an environment, we have organisms which began in the which began to take form in the environment, and so we have challenges to survival which the environment posed to the organism, and so the organism can come up with solutions, but this is based on okay. So, organisms have interfaces and ways of interacting with the environment. Organisms have ways of getting information, they have ways of making decisions and acting on the environment. And our hypothesis was that the more number of interfaces the organism has, the more complex its environment becomes, and the more complex the organism itself is. And we basically use complexity to define both the organism and the environment based on how many ways of behaving it has with respect to the world. And a special, I wish I was like this, but a special case of complexity will be created by social structures, which of course impose their own dimension, their own challenges of complexity. And of course, social structures in themselves lead to even more complex systems such as trading and finance and so on. And so summing up on the foundation of our model, we have the environment, you have organisms, you have challenges to survival which the organism must overcome. And we have interfaces which the organism has with the environment in terms of perception of getting information, in terms of being able to act back on the environment. Complexity is a simple term that we use. Complexity is a term that we use to describe the number of ways in which challenges can arise for a particular organism. So the next slide. So for a challenge to be successfully overcome, we have two criteria for what constitutes an appropriate solution. We have efficiency or speed, and we have effectiveness or the appropriateness of the solution. So,
can you use the full screen mode?
Yeah, I'm really sorry, but I've lost more than one slide. I don't know what's happened. I think this is correct. I'm just working on it. Okay, so never mind. This thing. Okay, so we're still on this because I don't have the slide, so it's disappeared. So we have okay. So basically, we've thought of complexity as posing challenges. Okay. Okay, so the basic mode of responding which the organism has is in terms of forming single stimulus response associations. So we have a problem, we have a solution, and we call this the F system, like short form of feeling, of course, but it's not exactly a short form, so just use the first letter of it. we haven't used F to exactly mean the same thing as feeling. So I'll come to this, the distinction of that a bit later. So basically, we've described the F system of responding as something which is quick, which is inflexible, because we have no single stimulus-response associations, by which the organism can make a specific response to a specific situation. It tends to be inflexible because it has only so many ways of responding, only so many problems. So basically, once you have a given number of, so once the organism it becomes too complex, and once there are too many problems which the organism has to handle, it can no longer go on creating F responses. So we have to hypothesize limit for the number of F responses which can be encoded by the environment. And so beyond this limit, we propose that the organism develops a T system, which is a slower, more general purpose way of responding, which is capable of responding in terms of evaluating specific situations and seeing what needs to be done. And so this is where you would have divergence between the two considerations, two criteria of efficiency and effectiveness, because the T is fast, the T is slow, but it might generate more proper solutions. The T is fast, the F is fast, but it might not be, but it's limited in the sense of being very flexible and rigid. And the T is slow, it takes more time because it requires more cognitive resources, but it also ends up being quite flexible because of its ability to respond to different environments and problems. So this is where we have the divergence between T and F in terms of efficiency and effectiveness. So just going back, the F system's responses would include what we normally think of as feelings and emotions, which have adaptive value, as we discussed during one of the previous presentations. So we have fear being an adaptive response in terms of preparing the organism to display fight or flight or freezing or falling, all those kinds of responses. And the T system would include things which we normally call thinking. But F and T are not the same exactly as feeling or thinking. So, because those words have many different meanings for all of us. So, yeah. So now I'll go back. So we have, to flesh out where the possible locations of F and T might be in the brain. This is one aspect of it which we haven't really given much thought to, the possible locations for the T system might be the cerebral cortex, among other structures, and the F would include the limbic system. Now this is, so we basically use T and F as a terms to construct a model on. And one of the propositions which we make, one of the claims which we make based on this T and F duality is that F has direct access to perceptual motor systems. So the limbic system will be more directly connected to the spinal cord and to the thalamus and to other ways of gathering information as well as behaving with the world. And we also suggest that T has only indirect access to all these systems. And T's access to the world, T's access and its ability to interact with the world is mediated via F. So T has no direct access. So,
you may want to hurry up because we have taken about half the time.
Yeah. So yeah, that is wind up quickly. So some of the propositions which we have are presented in the next slide, but we also suggest that the F creates problems. So problems are not the properties of the world which are out there. So problems exist only in the mind. The problems exist in terms of survival. So an organism needs to survive, and that's what creates problems. So the F system creates problems. It defines what a problem is. It delineates what the problem's parameters and means of solving them are. And very importantly, F also tells the T what would be an appropriate solution to that problem. So in this sense, the F creates problems for the T, and it also recruits the T when it may be necessary. This is why this is how we propose that survival biases the ways in which perception, cognition, so forth are distorted in systematic ways because we are not really impersonal logic machines. We are survival is essential to all of our actions and perception. So to answer the question brief in a very rough and preliminary sense, we conclude that F can exist alone because F in evolutionary time would have emerged earlier. But T, or the thinking system, cannot exist by itself because it feeds off the F. And so our conclusion is that things cannot happen without feeding. And now we move on to another set of on the part of the presentation, which will be taken over by my colleagues. So we made 5 claims based on the F and T model, and I think Rajat will.
Yes. So you have like 9 minutes left for all the rest of you.
Okay. So these are the basic 5 claims that we make, and these are, we can consider them as theme for the entire paper or the project presentation as well. So the first is FNT systems and the interaction between them can be explained by embodiment, which in some way she has handled. The other also is handled by Amita, is that T is dependent on F. The other thing is that since T is dependent on F, the other view of the same statement would be that F is independent and absolute. Now we will come to how it's independent. The third one is that F generates problems and filters the number of parameters in problems and situations and uses T system to tackle them. We are not very sure about the first claim that F generates problems, but that's how it seems through different situations and the problems. The fourth one is that our engagement with the world can be explained by the gradient model, which we are proposing through this paper, so we'll come to it. And the last one is that which is very relevant to the fourth claim, that F and T interact constantly and dynamically. So now let's get on to the model straight away, because I don't think we have much time to discuss the embodiment and the other issues. So when you think of a model, so consider that F and T systems and the definitions of F and T systems and the descriptions in the background, and certain assumptions that the system F is independent and absolute. We try to think of different situations to which different problems in the world, or the different engagements, the ways of engagements with the world that we have, or any organisms. But in particular, when we talk about this gradient model, we'll be talking it from the point of view of humans interacting with the world and not organisms in general. We have reasons to do so. So when we think of this engagement of organism, or specifically of humans with the world, we assume that the F system is independent, absolute, and the other part is the responses, the nature of responses that an organism, or specifically human, gives to different situations in the world would be composed of different contributions, contributions coming from the F and T systems in different proportions. So we propose that any response given to any situation will have combinatorial contributions from both the F and T systems. So that gets us to the model. So the model seems, so imagine a distribution of different responses to different situations that humans give, and the distribution to be linear. So we've got something called the F system that we described earlier at one extreme, and T system at the other extreme. So as we have discussed already, that F system can exist on its own, but T cannot. So when we think, so this model, so when we think of different situations and responses to different situations, think of a gradient that exists between this linear distribution of responses, the gradient of contribution from F system and contributions from T system. So if we assume a two-way gradient, so the gradient, 5 minutes. Yeah. So looking at the model from while moving from F to T, system F to T, we see that the contribution made by F system to the responses would decrease linearly, whereas the contributions made by T system would increase while moving from F to T. And these are the contributions to the responses to different situations. Now we also have a two-way arrow between this F and T to explain two more components. One is that F and T are constantly interacting, not only in terms of the contribution that they make to different responses to situations, but also in the sense that F creates problems, or say recognizes problems in the world and filters several parameters or different parameters that contribute to the solution, that might contribute to the solution of the problem. And T, since it cannot exist on its own, copes with the problems that F recognized or put in front of T, and tries to calculate and think rationally and get to the problem. So apart from this, so I'll give some examples. For example, okay, let's think of a person who's trying to learn how to play tennis. Now, tennis is something that is very tennis is not natural in the sense that humans have created it. Now, playing tennis would also mean that humans have created something called tennis and one needs to play it. Why does one need to play it at all? Because it gives us pleasure, it gives us happiness, it might give us something else. So that basically comes from F. The very motivation to play tennis comes from F. But while a person learns to play tennis, how is T involved in it? So the thing is that F drives the force to learn tennis, which is pleasure. So one has to achieve pleasure out of playing tennis. And but while learning to play tennis, there are different rules of the game that one needs to understand. And not only that, but there are different factors like you need to understand space, you have to calculate it, you have to understand what are the dimensions of the court and look at the court from the point of view of hitting the ball at different spaces. So all these calculations F leaves to T to make, and T does that. And after a while, this learning becomes automated. So it's like a loop which has a tangent out of it, and the tangent is that once you get to the stage of automation, you don't need to concentrate on the very basic rules of the game or the dimensions of the code, because you're kind of aware of them unconsciously, and you have different things to worry about. For example, the facial expressions or the confidence of the player opposite to you, and so on. So that's it. So there are some more examples that Prasida would like to give. One thing I forgot to mention is that think of the responses given to different situations as a slider here. So this slider can move here and here in the same situation while responding to the same situation, but will settle at one point definitely after a period of time. So I think you can take over.
To actually one.
So just to build on what he said, I'll just give you an example of extremes F and T's, and then we'll go on to a situation wherein both are constantly interacting with each other. So suppose if we have a bomb threat in a railway station. So it's purely feeling. So the instinct to survive, to save your life is acting. So that may be a rumor. You are not very sure about it. But still your F system springs into action and you immediately want to leave that place. No matter how much your T in the background may be saying that okay, it is a rumor, this is not confirmed information. So the F, this is pure F. And then say for T, we can take the example of solving an arithmetic problem, for example, just to cut it short. Now let's take an example. I had heard this incident in the news long back of a taxi cab driver somewhere in New York. He had found a bag full of dollars in his taxi after he left the passenger, and he took a decision to return it. And so that set me thinking that, okay, apart from believing that he may have been an ethical driver or whatever, what may have been the interplay of F and T here? So, to start with an F, he may have felt that, okay, if I keep this money, and he was an Indian taxi cab driver, so he may have felt that if I keep all this money, it would be good, because then it will help me in
20 minutes are up, so now you're eating into your discussion time.
Yes. So, okay, so there was greed first as the feeling system, but then after that he thought, if I do keep this money, what if there is a police investigation? So the T system is operating. So when the T system operates, he thinks that no, there is fear. Again we go back to the F system. So again when the F system operates, then he thinks, okay, so if I'm taking this money, I'm likely to get imprisoned. So what is the best way that I can deal with the situation? So he thinks that, what if I return the money to the owner? So again, T acting.
So again, when the T acts, then he says, okay, then there is a likelihood for reward. And if not anything, even if I don't get reward, if the media picks it up, I'll be a very famous taxi cab driver, and that way even my career reputation would increase. So again, so it goes back to the F as well. So there is again a long-term anticipation of reward. And so he eventually does that. So there is T acting on it. So that is sort of the complex interaction between F and T, although we cannot really demarcate it. It's so this coming to this last claim of F and T interact constantly and dynamically. And I also wanted to give this example of Satyam's chairman Ramalinga Raju and how the whole thing must have happened, and I thought, but then there is no time. So thank you so much.
Questions?
As you mentioned, the example of the pure F as fear stemming in and you decide to leave, and the moment you say you decide to leave, is a T coming in.
Yeah.
So can you ever say that there is a pure F or a pure T?
Well, it's difficult to say that there is a pure F and pure T because there is always this complex interaction.
Right.
So these points are not like zeros actually. But what we are saying is there is this F system, there is this T system, and this is a very rough model that we have. What we say that sometimes there is a likelihood of more of the F system acting, wherein there is a survival issue. So there is a bomb threat, and no matter what, it's like your F system gets into action, it springs into action, and it's almost automatic. You don't have anything else.
So the model is only for human behavior.
Yeah.
Because when you talk
Actually, it
about
explains several behaviors of animals as well. For example, a dog trying to do a trick to get attention of the owner. But then we are not very sure as to how generic the model would be for animals. We haven't really got into that. And the other thing is that I would like to mention that we haven't completely, so at some point of time it appears that the distinction between F and T is completely fading out. So we are not really sure, but the model explains, so I would say that almost all the situations that we have come across, we have thought of so far, and the responses to those situations. But yeah, that's...
Isn't part of the problem I see, as I see it, you may not see it that way. To conceptualize something like this as F and T, as separate and then thinking about interaction, simply think of it as a continuum, either one dimension or two dimension. There are much better explanations available.
Right, there's a reason for thinking like that. For example, consider the example of a robot, saying again the Asimov's laws of robotics, 3 laws of robotics. So that would be almost at the center of the T system. Because, but of course there is a value system for those robots as well. But then the thinking is completely driven by those 3 laws. There's nothing much to the F system that they have. We would call that the F system they have would be very simple. Or take an example of the brain damaged patients who cannot solve the restaurant question but can solve the acute very efficiently. So there is some distinction, and there are some hypothetical examples for which the T can be separated as well. But then, I mean, that cannot be. So that is why we see it as a gradient and not as 2 extremes.
I only have a complaint, which is that this is too abstract. I mean, I feel like F and T could be Fanta and thumbs up, and everything you said could be equally true. Meaning, T is dependent on thumbs up, dependent on Fanta. Fanta generates problems, thumbs up, Fanta. I mean, whatever. I mean, what I mean is that unless you tell me something about a real phenomenon, I mean, I don't see a single example. You can retroactively fit anything to this model, and is my worry. Yes, and because, which compounds me with the second worry, which is that you have a very generic model, you are justifying it on evolutionary grounds. I just don't see that argument. So, for example, I think a flexible system which reacts quickly to the world is far more important in some ways than a non-flexible system. And in fact, you could argue that all species, bacteria onwards, have flexible response system.
Right.
So maybe they're thinking first and feeling second.
The other point adding to it is that thinking of some situations where you do not immediately respond with the F system is that you rationally think if your colleague is getting promoted, that it's good for him. But then somebody pokes into you and then says that, oh, you should be jealous, and then you suddenly start giving it.
But I don't like this style of exploration. Meaning, you have hearsay, things like what if we were in a restaurant and I'm saying there has to be a better grounding of this kind of hypothesis because it's a very big model. So you need to perform a lot of tapasya to justify it. And I think what you should do is what I had suggested earlier also, is to strip it down to something very precise.
So at a very, very, very basic level, given that what you have said is true, perhaps, right? So what I'm saying is, are you trying to say, according to you, feelings are directly afforded? In the sense, if I look at, so if I'm seeing something as an object, so I'm not again talking about very basic things like fear, flight, everything like that. So the example that you cited, I'm saying that if I'm judging that I need to be jealous or something like that, and then I have the feeling, I'm saying that then at that very moment, I don't see how any form of dissociation can be made at all. I mean, in the sense I'm saying that just to feel is to think is to feel. Yeah. You understand what I'm saying? So there is no form of division there at all. So how do you deal with such instances? Because I can see that there are some, I mean, actually many.
I think one example where a concrete situation might help is the example that we originally taken was the ultimatum game.
Right.
I was hoping to see
that
something
seemed promising in the sense that say one person says that he's not satisfied with a certain amount, and the basis for that is what we would call a gut feeling or emotions, and they make sense in a larger context where natural interactions happen again and again, and one interaction would decide how the next would go on, and it takes into account all of that, which a conscious calculated procedure wouldn't be able to. And in that sense, the
advantage with the ultimatum game is that it kind of gives you two distinct pathways of reacting to a situation, responding to a situation. In the sense that one way would be that the person who has to accept the money would accept it because he had nothing and now he's getting something. But then how do emotions, again not immediately, but with a little thought.
Emotions or feelings?
Feelings, emotions. So that's why we call it app system. That's why we call it app system, because then we get into terminology. So how would app system trigger this thinking into the person that it's logical to accept money, but then it's not. I mean, I would be called a fool if I accept that, say, 1 rupee out of 100 and the person keeps 99. But then the problem with the ultimatum game again was that it was specific, but we felt that it was too specific, and we needed much more generic. Much more generic model to explain various situations, and especially the daily context situations, because getting something into robotics and say brain damage, I mean there are of course, you can explain on the basis of them also, but then the problem is that they are too hypothetical and sometimes too difficult to explore. For example, in the case of brain damage. So,
okay, I think time's up, unfortunately.